All are aware that a computer does not understand the language which we speak in our daily life. We generally write a computer program using a high-level language. A high-level language is one which is understandable by us humans. It contains words and phrases from the English language or other such as Spanish, be it French or anything else. But a computer does not understand high-level language. We need to ponder upon this fact. We need to convert the source code into machine code, and this is accomplished by compilers and interpreters, which will be talking in this video. We'll first move on with the topic interpreters. Now, whenever we hear this word interpreter, only one thing in our mind comes up, that is the actual interpreter which we understand in our daily life, who converts somebody else's language into the familiar language which we know. But what is an interpreter in actual life in computers? An interpreter transforms or interprets a high-level programming code into code that can be understood by the machine, or into an intermediate language that can be easily executed as well. Whenever we talk about anything, we must know from where its origin is. Then, let's see from where the interpreters of computers have come from. So, we move on with the topic history of interpreters. Interpreters were first used in 1952 to make programming easier within the limits of computers at the time. Interpreters were also used to translate between low-level machine languages, allowing code to be written for machines that were still under construction and tested on computers that already existed. The first interpreted high-level language was Lisp. Whenever we see something or learn something, we always have a question: why are we learning this? Or what is the use of this? What is its function in our daily life? Thus, we'll be moving forward with the function of interpreters. The interpreter reads each sentence of code and then converts or executes it directly. Interpretations happen line by line, and it can be stopped in the middle of execution to allow for either code modification or debugging. You may have seen a new term debugging in the previous few seconds. Now I'll define what is exactly debugging. The process of identifying and removing errors from a program when it results in the failure of output is called debugging. And don't confuse it with the actual debugging when we kill a mosquito. In the starting of our video, we saw the term introduction to interpreters and compilers. So now we have come upon that term, that is compilers. So what is a compiler? A program that converts instructions into a machine code or lower level form so that they can be read and executed by a computer is called a compiler. It's not a compiler, that is, it is not a clip which keeps our papers together. It's totally different in a computer language, as I have said before. Moving forward, we have the topic different types of compilers. Number one, we have cross compiler. A cross compiler is a compiler capable of creating executable code for a platform other than the one on which the compiler is running. Number two is bootstrap compiler. A bootstrap compiler is written in the language that it intends to compile. Number three is decompiler. A decompiler is a computer program that takes an executable file as input and then attempts to create a high-level source file which can be recompiled successfully. Number 4 is source-to-source compiler, a program that translates between high-level languages is usually called a source-to-source compiler. We know that what is our interpreter and what is the compiler, we often get a question, a compiler or an interpreter, what should we use? Let's see a little more brief about a compiler and an interpreter. A compiler takes entire program and converts it into object code, which is typically stored in a file. The object code is also referred as a binary code and can be directly executed by the machine after linking. Examples of compiled programming languages are C and C++. An interpreter directly executes instructions written in a programming or scripting language without previously converting them to an object code or machine code. Examples of interpreted languages are Perl, Python, and MATLAB. Compiler. It considers the completion of your program as input for converting to machine code. Number two, it usually generates intermediate code in the form of the object file. Faster execution is control statements as compared to the interpreter. Detected errors in the program get displayed after the entire program is read by compiler. Example C++ and Java. Interpreter. It considers one statement in your program at a time as input for converting to machine code. It doesn't create an intermediate object code. Slower execution of control statements as compared to the compiler. Detected errors in the program get displayed after each instruction read by the interpreter. Example, Basic, Python, PHP. Conclusion. Thus, we may conclude that both interpreters and compilers are efficient and useful in their own ways, and we can't say that one is better than other. They may be better from each other in one way or other, but as a whole they have their unique contribution to the computer world. Thank you.